Beta oxidation is the process of converting fatty acids into acetyl-CoA. Triglycerides are made up of a glycerol molecule and 3 fatty acid chains. Fatty acid chains are highly efficient energy stores as they provide more energy per gram than carbohydrates, such as glucose. In highly active tissues, such as the heart and brain, 50 to 70% of energy is provided by fatty acid beta oxidation. Free fatty acids are found in the cytosol, and in order to be metabolized, they need to be activated by acyl-CoA synthetases found on the outer membrane of the mitochondria. This adds a CoA group to the fatty acid, forming a long-chain fatty acyl-CoA molecule. The fatty acyl-CoA molecule then enters the intermembrane space of the mitochondria, where it is modified by carnitine palmitoyltransferase 1, which replaces the CoA group with a carnitine group, forming acyl-carnitine. Acyl-carnitine is transported across the inner membrane by carnitine acyl translocase, and on the inner membrane, carnitine palmitoyltransferase 2 modifies acyl-carnitine back into acyl-CoA. This process is known as the carnitine shuttle. Beta oxidation is now able to take place, and the process involves 4 enzymes: acyl-CoA dehydrogenase, enoyl-CoA hydratase, 3-hydroxyacyl-CoA dehydrogenase, and beta-ketoacyl-CoA thiolase. The process is separated into 4 steps. In step 1, the long-chain acyl-CoA molecule is converted into trans-2-enoyl-CoA by the enzyme acyl-CoA dehydrogenase, which reduces FAD to FADH2 by accepting 2 hydrogen atoms. In step 2, the trans-2-enoyl-CoA molecule is converted to 3-hydroxyacyl-CoA by enoyl-CoA hydratase, which releases a water molecule. In the third step, the enzyme 3-hydroxyacyl-CoA dehydrogenase converts 3-hydroxyacyl-CoA into beta-ketoacyl-CoA, reducing NAD+ to NADH plus H. In the final step of the reaction, beta-ketoacyl-CoA is converted back into acyl-CoA, but with 2 carbon atoms less. This is catalyzed by beta-ketoacyl-CoA thiolase and requires CoAsh, also known as coenzyme A. This produces 1 molecule of acetyl-CoA. The shorter acyl-CoA molecule then returns to step 1 to start the process again, and this carries on until all the chain has been converted into acetyl-CoA molecules. The acetyl-CoA molecule is then able to enter the Krebs cycle so that it can be further metabolized.